Yo, 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 what's going on? It's your main man, Trade Digital. Trade Digital right now. We got a special episode today. We're going to code face detection. Face detection, we're going to code object detection, and we're going to be able to talk more about opencv and what it's about. Because opencv, we're going to be doing a whole tutorial. It's going to be a couple of series. So we're going to be in the beginning phases. We're going to print out um, certain pixel pictures. Like we're going to pull out pictures for the internet. We're going to print it out. You're going to see the pixels, the amount of pixels an array it have, because each picture have three-dimensional, two-dimensional arrays, and those represents the pixel colors. That's how it detects the image size and all that good stuff. So let me first stop sharing this, and then we're going to go to our slide because I have a slide, but I teach this course as well. So if anybody want to take a course and take a lesson with me, you can also go to Trade Digital 89 Trade Digital 89 on Instagram. Wait, hold up 1 second. I'm not sure that's my Instagram. Wait, or matter of fact, you can go to my main Instagram account. Big Lion 31 is BIGLYON 31. You can go there. That's my main page. You can hit me up on there. All right, so we can get right into it. The first thing we're gonna share, I'm gonna share the slide so we can get an idea what is opencv. That's the first thing we're going to do. So let me see my PowerPoint. Yeah. All right, we got it right here. So I'm going to share it on the screen. All right, let me full screen it. And let me go to, hopefully you can see it. All right, so what is opencv? Opencv stands for Open Source Computer Vision Library, which is widely used for image recognition or identification. It was officially launched in 1999 by Intel. It was written in C++ in the early stage, but now it is commonly used in Python for computer vision as well. It's a great tool for image processing and performing computer vision tasks. It is an open source library that can be used to perform tasks like face detection, object tracking, landmark detection, and much more, which is equal video capture. We can access our webcam using pass0 in the function parameter, and you want to capture CCTV footage, then we can pass RTSP URL in the function parameter, which is really useful for the video analysis. So you see this picture right here. You see this is basically detecting this picture right here. So it's detecting people. It does a body detection. It does eye detection. It does face face detection. So in this particular picture, it's detecting a few people's bodies, whole bodies right there. So we're gonna get right into it. But first thing we're gonna do, we're just gonna do opencv. We're gonna print a simple picture that I already have already. So let's go to the code. Let me remove this. Then we're gonna go right into the code. All right, let me stop sharing and let's go right to Atom. If you can use Atom, I'm using Atom, or you can use VS Code or Python idle. You can use whatever you need. So I'm full screen right here. So the first thing we want to do is we want to import CV2. So CV2 is what we use for opencv. So why I'm not here. Okay. So we're gonna import CV2, and then we're also going to import NumPy as MP. And the reason for that, when we capture a particular image, I want to also show you that we can actually see the pixel numbers with the arrays. If you looked at my other tutorials, I was talking about how we had NumPy arrays, two-dimensional array, three-dimensional array, four-dimensional array. So I was talking about that. So you can go to my latest videos with that. All right. So the first thing we're going to do is we're gonna create a variable called mig for image, and then we're going to do cv2.imread. And then inside our parameters, we're going to put our whatever picture. So I'm gonna take a picture of Roman Reigns. I already have it already. So this would be a picture of Roman Reigns right here. So you could download whatever picture on Google. You could save it, and then you can, pull it out. You can actually just put Bloodline. This is the name of it, Bloodline.jpg file. But I'm gonna just do it like this. If anybody have issues, if they just put the name of the picture file, JPEG. If it don't work, you can do it this way as well. It could go right into your directory. And then we're going to put, so after that, we're going to put comma, we're going to put 1. And the 1 is going to represent the regular color image of that. So once we did that, all we do is cv2 dot I'm show. This is to show the image, and then we'll just put the name of the image bloodline, and then we're gonna put comma, and we're gonna put our variable name img, and then we're gonna put cv2.wait key. And wait key is important because that's how the image pop up. So we have the duration time of the when every time the image is open, and then we want to destroy it after once we click it. So we're gonna put cv2.destroy. You might see it on here, destroy all windows, and that just be an empty an empty argument or parameter. So that's what we have. So let's run it. All right, I don't know if you see it on my screen. Let me see. Oh yeah, you don't see it on my screen. So what I'm gonna do is I'm gonna share that part. Let me see. Let me share it. I'm gonna share that part of the screen so you can see the image that popped up. I'm using StreamYard. All right, you see this is the bloodline image. You see, so it pulls out that image. You see bloodline on the top. That's what I named. I named that particular image. I named the bloodline, and then comma is the variable that I created for img equals cv2 I'm re in the picture file. So that's why I put 1. So it's going to be this particular color that that is gonna open for this picture, and then cv2 dot wait key 0 just represents the duration time, and then I could just X that particular picture out. It's gonna destroy the window. So you see me again. So yeah, that's very, very simple opencv. Let's go back to the code. Before we do any type of face recognition, we're going to do other things with it. Let's go back to the code. So that's what I'm saying. We can do other things with it. We can we can also print the array. So we can do, let's do this. We can do print image. We could put print image right here, right? Hold up. Let's exit out. And then if you see right here, we print the image, you see it have a 3-dimensional array. Now these 3 numbers represents the pixels. So they have something called BRG that represents blue, red, and green. So these represents the pixels. So it's a 3-dimensional array with that particular picture. So you see the 3-dimensional arrays right there for that particular picture. So now if let's say we want to check the shape of it, so we can do print. We want to find the shape of this. So you remember img.shape. So this gonna be what we can find for the shape of it. So we can manipulate it so many different ways. So the shape of it is finding out the size of this. So it says 1000 by 799 by 3, and the 3 represents the 3-dimensional array because it have those 3 pixel colors, blue, red, and green, which is BRG. So that's what you're gonna see a lot. So we won't go too far into that. That just show that we can check the pixel size and all of that, and things of that nature. There's other things we're gonna do, but we wanna go right to the recognition part. So that just shows that. Now let's go to the recognition part, because the recognition part is gonna we're going to be able to detect we're going to be able to detect the face or object in that particular picture. So I want to read something first, because let's go right here. Let me stop sharing so you can understand the facial recognition while I'm coding it at the same time. So we're gonna share that screen. Let me see if I have it here. Yeah, here we go. So this is on realpython.com, and this is resources that you can use to practice your code. So certain codes that I'm doing is going to be very similar to this. So let's read it. Let's read it together. So the first thing it says, we ain't gonna read all of that, but this is installed in opencv. So I found that installing opencv was the hardest part of the task. If you get a strange, unexplainable error, it could be due to library crashes, 32, 64-bit differences, and so on. I found it easiest to just use a Linux virtual machine and install opencv from scratch. Once you complete the installation, you can test whether or not it works by firing up a Python session and type it. So the first thing, also for people that's having trouble with opencv, you're gonna go to pip install opencv. Um, once I stop explaining that, I will show that part of it. So you'll do pip install opencv. So this is understanding the code. So you see the code here. We'll start it here. So it says create a hard cascade. Now we create the cascade and initialize it with our face cascade. This loads the face cascade in memory so it's ready for use. Remember, the cascade is just an XML file that contains the data to detect faces. So the cascade that we need to implement, we can use a variable called face cascade for it to detect the face detection. So we're gonna use this. This would be a similar code I would use. Face cascade equals CV2 cascade classifier. So the cascade classifier is going to implement whatever cascade we use. And we use an eye cascade, or we use a face cascade, or body cascade, or so on. So that's what we'll be using. Right here is to read the image, of course. We pretty much did this. Here we read image and convert it to grayscale. Many operation opencv are done in grayscale. That's just basically, grayscale is basically the image that you see and the colors and the pixels. This code is important as well because this detects the pixels, so it can be able to detect where the face is located at. So it says detect face and image, face equal face cascade, detect multi-scale. So it's detecting. You see when we able to print out the image, we saw all those three-dimensional arrays and the pixels. That's how it's going to detect where the face is at. So it's doing all these calculations to detect this. So it's going to be scale factor equals 1.1. It's going to be min neighbor equals 5. Min size 30 by 30. Flag CV2 CV hard cascade image. So it's detecting that particular image based off its calculations for the pixels. So it's extremely dope. Let me fast forward that. So we can just read this real quick. The detect multi-scale function is a general function that detects objects. Since we are calling it a face cascade, that what it detects. The first option is grade cascade image. The second is the scale factor. Since some faces may be closer to the camera, they appear bigger in the faces in the back. The scale factor compensates for this. The detection algorithm uses a moving window to detect objects. Mint neighbors define how many objects are detected near the current one before it declares the face found. Min size, meanwhile, gives the size of the window. So we discussed that. And this is another function that you'll see. I could explain that without even going through this, but basically X and Y is the axis. So the X would be across, that'd be in the bottle, Y would be vertical, right? Then you have W represents the width of it, H represents the height of it. So you're gonna loop all those things into the faces so it could detect the rectangle in each size, in each four sizes. The width, the height, the vertical, horizontal. It's gonna detect that particular rectangle in each of the sides. That's how it's doing these calculations. The image is the variable name that we added, the X and the Y axis, and then we're gonna add X's plus the width, Y plus the height, and 0, 255, and 0. Remember what that represents. That pretty much represents the pixels. So blue, green, red, BGR. So this would be blue would be the first one. So we put 255 there. That would be blue. So it'll have the rectangle in a face. It'll detect that right there. 2550. And then you have 2 for the last one. That's just for the pixels that's going to detect. So let's just begin the code right here since we was able to explain that. I wanted to brief up on that so we can get a clear understanding before we start the code. Let me see. All right. So far that's what we did so far. So the first thing we're going to do is we're going to create a variable under here. So hold up, wait a minute. All right. So first we're going to create a variable right here, and the variable name is going to be faces, and then we're going to have that to equal to cv2. You remember dot what? Cascade classifier. Cascade. You might see it on mine. Cascade classifier. This is going to detect the face that we're going to get for this image. Now we're going to do cv2 dot the data dot hard cascade, HAR and cascade, and then we're going to concatenate that. And we're going to use something because they have to be able to detect that XML file. We're going to do hard cascade underscore frontal face, and then underscore is going to be, we'll do default dot XML. So we're going to do default.xml. That's just going to get that particular XML file. And also in your computer, you'll see hard cascade a lot when you go to like your the video part of the computer, like when you do streaming, you'll see that a lot. So it'll be familiar. So we're just taking a frontal face of the particular image. So after we did that, we're gonna create another variable. So we're gonna put img, and it's going to be underscore. Let's just do underscore gray. We have that to equal to cv2 dot. You remember cvt color. We're gonna do cv2 color, and then we're gonna put the variable name. The variable name, you remember here, this is the image, so we're gonna be using that. So it's gonna be img, and then comma. We're going to put cv2 dot, and then in all caps, you're gonna put color. And you see right here, BG2 to gray, blue, green, red to grayscale, pretty much. So when you see BGR, that really means blue, green, R. Those 3 numbers in that particular array. So now, since we got that, we're gonna create a variable called detection. Now this time to detect the image, right? Detect the faces in our image. With this is extremely important. So we're gonna do detection is equal to faces. Faces, that's the name of this variable up top, and it's gonna be dot detect. So it's gonna detect. I think I had it in the bottom. I might not have it. Detect multi-scale, and then the scale got to be capital with a capital S. And then inside here, we're going to put our variable because it gotta be able to detect the images and the pixel colors. So it's gonna be we're gonna put you can copy this img gray. So we're gonna copy that. We're gonna put it inside this argument img gray, and we're going to you remember scale factor that we saw when I was reading on that page, the python.com. So we're gonna put scale factor. Scale factor is important because we want it to be able to equal to 1.1, and we're gonna have the min neighbor. I don't know why it's not popping up for me. Min neighbor, and this is going to equal to. And we're gonna have it equal to 6. So this is detecting everything in that image we're gonna have there. So now, since we have that so far for our detection, we're gonna create our for loop. This was easy. This was the pretty much the same thing that we saw on that particular file. So we'll do for, and then we'll put right here x, y, w, and h. So it's gonna be looping. It's gonna be looping the sizes in that shape inside the faces. So that's why we're gonna put in detection, which is right here. All right, about time to have that in detection. So so the detection with the face detections, we're gonna be looping the x-axis, the y-axis, the width, and the height. So now what we're gonna do right here, we're gonna do cv2 dot rectangle. All right, that popped up. Rectangle. Then it's gonna be img, that variable right there, and then it's going to be the x and y axis. Then it's going to be the width plus, we do the x plus the width, and then which thing we're gonna do here? We're going to do, or we could just, yeah, that would have been wrong because that got to be together. So it's gonna be the x. So it's gonna be right here. It's gonna be the x plus the width, the y plus the height, and then we're gonna put a comma, and then we gotta put the pixels. So I wanna make it red. I mean, should I make it red? All right, so we'll do 0, 0, and then we'll do 255. Because I want to be able, because the bloodline with the color red, and then we're gonna do 2 right there. So what it's doing right here with this for loop, we're looping the sizes from the y-axis, the x-axis, vertical, horizontal, the width of it, the height of it is looping to detect the particular face in that particular image. And the detection is precise with this formula right here to make sure it's detecting the image from the face, so it can know, okay, where's the pixels that we detected for this multi-scale? Where's the pixels that we're detecting? That's why we use I'm gray, because this is going to detect the pixels with blue, green, red to gray. And when we print that out, we saw those 3 arrays that we have there. So now since we got that, it's pretty much over from here. We don't have to put this here, and then we put bloodline. We should see it. Let's see what happens here. All right, so we have an error. It says has no attribute of hard cascade cv2.data. So let's see what the issue. If anybody have problems, we're gonna find it. That's on line 6. Let's see what issue I have here on line 6. Okay, I see right here. It's hard cascades with an S right there. All right, so it's loading, and let's show it. Let's show the finished product. So make sure you put an S at hard cascades right here. All right, I see the image. Now let me be able to share my screen. Let me stop sharing and share my screen so you can be able to see it. And there you go. There you have it. So you see it detect the faces from the Usos and Roman Reigns. It was able to detect that particular image. So it's pretty cool how it works, how face recognition, face detection, how it works. It could be able to detect faces, bodies, objects. So we want to grab the belts, it's able to do that. But today we just wanted to take it easy, take it slow, and just do face detection with image. The next video we'll do face detection. We'll do face detection with actual video, so you'll actually see it detected my face in the video. So I hope everybody enjoyed this video. Let me see if I can add myself right here. Okay. Hope everybody enjoyed this video. Please like and subscribe, share it, and just try it yourself. It's pretty dope. And all the high level jobs, if you can do this, you'll get it like it's nothing. So please like, subscribe, all that good stuff. And yeah, I hope everybody enjoyed the video, and we can end it here. My name is Deshaun Lyons. This is Trade Digital 89, and peace out.